Welcome back everyone. In this video we're going to talk about units and timescales. The units that we're going to be addressing in astronomy are SI units. And SI units are the international system of units that are most commonly used. And there's another one called the US customary units, such as pounds, foot. But we're not going to use this in this case. We're going to use SI because they're recognized in astronomy and in other sciences as well. So in the international system of units, we have 7 basic units. And the first one is time. And this will be in seconds. The second one is length. This will be in meters. And then we write S for seconds, M for meters. The third one is mass. So the mass that we use is just kilograms. kg. Fourth one, for the next one, we have temperature, which is an important component in astronomy, and we define this in kelvins. K. For the next one, we have electric current. Electric current isn't commonly used, but you will still have to know these, as these are the basic units. And this would be in amperes. A. Now we have amount of substance. So if you've heard of Avogadro's number, we define this in moles, and there's a specific number for that. And the amount of moles would just be in M, and this would be 6.02 times 10 to the 23rd of the amount of substance that you have. The last one, we have luminous intensity. And then we define these in candela, so CD. We just covered the 7 basic SI units, and now we're just going to go ahead and cover scientific notation. So there comes a time when we have too many zeros. For example, let's say 1 billion. So we have 9 zeros in 1 billion, and this is actually equivalent to saying 1 times 10 to the 9th. And let's see how this works. This number right here measures the accuracy of your value. So if we increase the numbers after the decimal, pretend 1.001, these numbers are more accurate than just putting 1. And always remember, this is accuracy. For this number right here, it becomes positive when the number is greater. So when we increase the value, when the value increases, this number right here also increases. And when we decrease the value, pretend we become less than 1, but go closer to the value of 0, then this number will become negative. So for example, let's see 0.001, and how would we put this in scientific notation? Because it's moved 3 decimal places over to the right, we can say that this is 1 times 10 to the negative 3rd, because it's 1, 2, 3. We would express it like this. So a simple way that we can understand this quite easily, and a method that actually worked for me, is knowing that if we have 10 to the 3rd power and 10, let's say 10 to the negative 3rd power, a negative sign will always mean that it's moving to the right. So 0.001, that means that this value will always get less or decrease. And then if we have a 3rd power, we're putting this to the left. So we're saying that this value will increase by a factor of 10 times 10 times 10, and that would be 1,000. we're reducing this by a factor of 3. So now we will talk about significant figures and how it relates to accuracy. So what I was saying before was this number right here measures accuracy. And let's say we have a number like this, 1,000 right here. How many sig figs is 1,000? So we have actually a couple rules. Only one counts as 1 sig fig. So you might ask, why was that the case? There's 3 rules that we can abide by. And the first one is that non-zero digits are always significant. So what does this mean? This means that any number that isn't 0 would be counted as a sig fig. So for example, if we have 1, 2, 3, 4, this would be 4 sig figs. 4 sig figs. If we have 1, 2, 3, 4, 0, only the first 4 would count as sig figs. Our second rule is that any zeros between 2 sig figs are significant. So this means that if we say 1,001, we're going to count all of these. So we would have 1, 2, 3, 4, 5. 5 sig figs for this. However, if we say 1,000, like our last example, we would only have 1 sig fig because we would only count the first one since all 3 are zeros. And we gotta abide by our first law. So the third law is that a final 0 or trailing zeros in the decimal portion are only significant. The final law actually tricks a lot of students in general, and I think a great example would be a number such as 0.00500. So what would you say, considering this rule, as the amount of sig figs for this value? So if you said 5, then you would be considered wrong because only the last 2 zeros of these count, since it's the trailing zeros in a decimal portion that are after 5, and 5 is counted as a sig fig. So we would count these 5 as count these 3 as the significant figures. So we would have 3 sig figs in this case. And if we do another example such as 0.03040, we would count the 0 in here because it's between these 2 sig figs, these 2 significant digits, and we would also count the 0 because it's after the sig fig, but not the 2 zeros here. So we would say this has 4 sig figs. We will continue the sig figs and the timescales in the next video. Thank you for watching.